Okay, so hello again. This is the next part of the Programming Bootcamp series. And let me switch to the sharing of the screen. And before we continue with the solutions of these exercises that we saw earlier, I just remembered something that I forgot to tell at the beginning of the series. So I just show you one of the first slides. And I mentioned that if you press question mark, that you can see all kind of keyboard functions. One of them is the letter H, if it's in a focus. And if I click on letter H, then it adds all kind of hidden texts. So some of the slides, not all of them, have extra explanations. Explanations that many times I say or don't say or whatever. Anyway, you're welcome to open them. I don't show them during the slides because then it would be just way too much text, but you can feel free to open it when you need to come back to the slides and view them again. There are some text. Okay, and more places to have typos or grammatical errors. Anyway, let me move this thing down here. It's gonna be easier this way. Yeah, so we had the exercise in the last video, and these were the exercises. So let's go over now the solutions and a couple of solutions. So the first one is we had the width and the height and the area that we already had. So we wanted to calculate the circumference, which is 2 times the width plus the height. But we had to use the parentheses because, well, at least the way I remember in math, the multiplication is just like in math. So the rules are the same as in the math, that the multiplication is stronger, or it goes from left to right. I don't even remember anymore. Okay, the point is that actually that's an interesting point. There is what we call operator precedence, that in math you might be used to, or what comes before which mathematical operation, but in a programming language, all kind of other things are operators. So the equal sign is an operator, and the comma is an operator, and all those are in this table of operator reference. And of course, you don't have to remember them. Slowly, we'll know the obvious things, and wherever you have doubt, you can just put in parentheses as you would normally do in math, and that's it. So in this case, we had to put in the parentheses, so it's going to be 2 times the sum of these two numbers, and that's the circumference. The next exercise was, or next solution is about a circle. So we have a radius, just some number, 7. I have a variable that I created. I called it pi and put the 3.14 in it. And then I can use the regular formulas just to calculate the circumference and the area. So it's r times r times pi and 2 times r times pi. And that's sort of the straightforward solution. But then there are a couple of other things that I can show. So for example, some people think, and rightfully, why do I need to write the pi here? And it's not really exact, or it's very far from being exact. Obviously, you don't have an exact pi, but you can have a much better approximation. So Python has a module, and we'll learn about all kind of modules later on, that you can, it's an add-on to Python, but actually this comes with Python. So usually you have the language, and then you have the language, you have these all kind of import things that you can import, but they come with the language. So they are built-in add-ons, let's say. And then there are all kind of other things that you need to install and then import. Okay, but for now it's okay. So we have the math module, and we import it. That means that now we can use all the functionality that this module provides, and specifically we do the math.py, and then we use this. So now instead of having our own pi, we have this math.py, and you see the result is a much more exact number. a much better approximation to the actual value. Okay, and there are tons of these, so you can we can look at this. We can math.
Yeah, I was gonna ask to do that.
Python. Okay, so let's search for math Python. Did I spell? No, I didn't even spell that correctly, but Google found it anyway. So this is it leads to the python.org, math Python. So that's where the documentation is. And then you can look at ceil and comb and whatever, tons of variables. So floor is like taking the integer part of a number if you have a floating point number, and ceil is taking the whatever it's called, the number, the integer that's just above the floating point that we have. So yeah, it explains the smallest integer greater than. Okay, and there are tons of these functions here, and you can't remember them, obviously. But when you need to have these functions, then you can look up what kind of functions exist and how do they work, and lots of interesting things. Okay?
So is this math add-on a library, or what would you call it?
It's you can call it a library, you can call it a module. These are usually the names I think the people use. In many cases, it's just some more Python code.
Right.
Some other person, somebody already wrote. Okay.
Right.
Somebody is lower level and it's maybe written in C if it's something that needs to be fast. But from our point of view, that doesn't really matter. We could actually look at the source code, how this module is written. Maybe it's written in Python, and then we could actually read how all these things are implemented, which can be an interesting thing to learn. How do people implement, I don't know, whatever is QRT means, okay, all these functions.
And it doesn't only have functions, right? So when we use py, right, math.py, that's not a function, is it?
Yeah. So yeah, so that's a really good point. So basically, each of these modules has two types of values. One of them are usually called attributes, which are some fixed value, like pi was, okay, in our case. And the other ones are functions, sometimes also called methods. It more or less meaning the same thing, that do something. So that's they actually do some work and then return usually some result. These functions sometimes get some parameters, like ceil, for example, gets a value and returns you something, and others get more values, and some of them, I don't know if there is any here now, but some of them might not get any value and just calculate something and return. For example, think about another module called time that has a function called time that doesn't get any input but returns you the current time. So it works, it needs to work because it has to look it up and find something. Okay? So
right.
You don't have to, not all of them get actually parameters. Okay? More questions here?
No, I think that was it.
Okay, that's good questions. So yeah, so this is what we did here. We used pi, and then actually I think some people even asked how could you write instead of r times r on the second exponent, but let's
r squared.
Sorry.
R squared.
And I think it's the caret sign, right? In
yeah, but that's
double stop, right? So actually, I'm going to show you in a second something that I'm not even sure when are in their slides, but it's a good opportunity to show something. But let's go to the last example, which is a rather simple one. It's just some work. And that you have the two variables, and then you have the four operations. So let me show you something that, I need, what was that? Anaconda prompt, right? This is what I need. And here, I don't need to go any directory now. I can just type Python on the command line, or Python 3 if you are on Linux and then you would like to use Python 3. And now we got into what we call the interactive shell. This is something that happened to us by mistake when we added -v, lowercase v, but we didn't want it. And then it also printed out all kind of interesting output, or I don't know what was that. Now we get into the interactive shell. So the earlier, I showed at the beginning of the series, the course, that if you open the terminal or the command line, you can talk to the Windows operating system with commands like dir and cd, and there are a couple of others. Now, if you ran Python, we didn't tell it to do anything, so it started to give us an interactive shell where we can now talk Python to this thing, and it will execute the Python code that we type in. Earlier I mentioned that this thing that the C users Gabor Szabó with the greater than sign is the prompt. The interactive shell has these 3 greater than signs as the prompt. And this is, when I see this, I know that I can type in. When I don't see it, then I know that something is still working or still waiting for some more input, that I haven't finished something. So I can type here 2 + 3. And I don't even have to say print, because it already automatically prints the result. And now I'm doing Python operations. So I can say 3 × 3, okay? And then I can play around and see, okay, I don't remember what was the operator of the power. So maybe it's the caret, so 3 on the second. Well, it gets 1, so that's not the operator, okay? And of course I could read about it, but that's the easy way. Let's do it the experimental way. So the other operator that I might recall is the 2 stars, and that looks right, okay? Of course I need to read it and whatnot, but in more complex situations, the interactive shell can be a really nice way to experiment with code in Python. So I could now also say, okay, A = 3 and B equals to whatever number, and see if you can, sorry, I have to drink. So you can now use A and on the power of B. So you can play around with this, and you can do all the other things. And if you are already here, you can do here import math, okay? So now the interactive shell also has math. The interactive shell also has a command called dir, okay? Which is different from the dir command of the shell outside, okay? It's just the same word. Just think about it as in Spanish and English, you have same word. You can have the same word, but different meaning, okay? And so here too, dir is just another command of Python that lists all the things that we have in the interactive shell. And as you can see, there are a couple of these underscores, things with underscores. These are built-in parts of Python that we don't care about them for now. We also see the A and the B that we created when we assigned values, and the math that we just loaded. If I ran this dir before I did any of the operations, it would show me the list of all these things, but without the A and B and the math, because these are what I mentioned already, the word objects that have the library, that has the language has right now, okay, or my runtime here has. So currently Python is running, and I am sort of inside of it, so I can create these objects and use these objects. So the dir showed me what kind of things do I have in this in the program. But remember, we imported the math, so we can ask with the dir to list all the attributes and functions of math. So we looked up in the documentation to see explanations about them on the internet, but you could actually get here And when you have an object, you can see, oh, these are all the things that I can do with the mass object. Now here you can't really see if this is a function, and where is, I lost pi here, and pi is an attribute. So from this view, you can't tell it. And for that, you'll probably need to do more work. But you can at least see that you can have all of these things. And sometimes it's important to learn this way. Okay. What else can we do? So there is, okay, so there is also another module that I usually show. It's called sys. I can say dear sys, and it has lots of things. For example, sys executable, I think. That's where the Python exa is. So Python knows where is the executable, the Python interpreter is. And you can, in your program, so you can use the sys also in your own program, just as we use the mass. And then you can interrogate the program and ask your program, okay, where is actually Python? And you can ask also, let's say here, you can say version info, I think. You can ask what version of Python do I have? So I think version info, and then I say, how do I do? Major, I think that's the way. It says 3. If you were running on Python 2, this would give you Python, the number 2. So in the program, you could actually check easily what versions of Python you're running right now, and then you can write code that say, okay, you can recognize that you are running, let's say, on Python 2, and tell the user, no, you can't run it on Python 2. Before you get to the point where it starts giving all kind of strange errors. So if I started to run some program that can, so there are things that only exist in Python 3 and not in Python 2. So if you write in Python 2, if you run it in Python 2, you will get a syntax error or some error. And now what happens is that you write your code and you give it to some other person. And and you wrote it for Python 3, and the other person runs it by mistake or on Python 2, and they get a syntax error. So they come and they say, oh, your program is broken because it has a syntax error. While your program is not broken, the way it was used was incorrect. So you can put, for example, some code in your program to first verify that you actually are being used, or the program is being used on the right version of Python. And if not, then give an error message. No, this program needs Python 3. And then it's easier for the user because they can already fix the problem that they got into, and they won't blame you. So it's a win-win in the end. Okay, so these things, there are lots of other things that you can do. Now, how do you get out of this? Obviously, you can type exit, right? And then Python says no, no. And this is like the major point of Python. What Python says is, I understand completely exactly what you mean, but I won't do until you type it exactly the way I want you. Okay, so it says that you have to type in exit and parentheses, and that's how you exit. Okay, so it's a little bit funny of these things, but you have to type it correctly, because what we are doing here is actually calling the exit function of Python. So you could also have it in your own program that you say, okay, I'm doing something with my program, and I encountered some issue. Maybe the user gave me a name of a file, and I was supposed to work on the file, but the file doesn't exist. So I won't go on. I just exit. I give an error message and I exit, for example. So I can use it to early exit from the program. Any questions here? Is the interactive shell or?
No, I think
No.
it's
Okay.
quite all right now.
Okay, good. So we go on with the next chapter. I don't know how many. Well, I've been talking for so long already, so I don't know how much time we are going to be able to go on with it. But let's go on with the next second chapter that I couldn't give you a better name, so I just called it second steps instead of first steps. because just the first chapter got really wrong earlier, and then I tried to use. And actually, I think I see that some of these things I mentioned now with the interactive shell, but let's go over them. So modules, I said that there are these modules, for example, the sys module that you can import, and then you can have all kind of things you can use in there. And we know how to find the documentation just by searching on Google or running dir or whatever. And specifically, the sys module comes from the, I think the name comes from that this is the system of Python. Okay, there's also another module called OS, which is operating system. So it's all kind of things about your operating system, which is Windows or Linux or whatever. But sys is all kind of things about Python itself. So executable we saw, that points to where the Python executable is. This was taken in a Linux machine. The other one we saw on Windows, it's Samsung exe. Platform. So here it's Linux. Well, actually, you know what? There is the examples basics modules. Sorry, let's run it here as well. CD, it was work, slides, Python, examples, basics, right? Sorry for this. Basics and module spy. So I run this on Python module spy. So this is what I get when I run it on my Windows machine. I get in an exe, I see it says that the platform is Win32. Okay. Here in Linux, it said it Linux. Okay. argv we're going to see it soon. argv in the zeros place is the name of my own name, my own file name. So here it was executed from the upper directory. So it was executed as Python examples basics module spy. So it is called, it thinks about itself as being called examples basics module spy. Basically, you can reflect yourself, your own script, so you know how you are called. What's your name? It's especially interesting when you're renaming a program, renaming a Python file. So you still know that you can still refer to yourself, not some other name that you actually fixed in the program. So now that I ran it, I CD'd a change directory into the basics directory. So therefore, it calls itself just module spy. If I go one directory up and I say Python basics module spy, then now it calls itself basics module spy, because this is how I code it. Okay, and then the other things is the major version number that I showed you, and then there is another thing, that's another interesting thing. So the get, these are all attributes, right? So nothing happens there, and this is a function already. And the get size of it, I think, more or less the only function that sys has. It gives you how many bits are used, so how many bytes, not how many bits, how many bytes are used by some object in your program. And that's an interesting thing to see, just a little bit to understand what's going on. So here, if I check what is the size of number 1, so how much space does it take in the memory of my computer? And it takes 28 bytes. Normally, I mean, if you had a C program, this would take 2 or 4 bytes. In Python, it takes a lot more bytes, it takes a lot more space, but that space gives actually a lot of flexibility that Python provides. So that's the trade-off. And that now I can tie it back to what we talked about NumPy, that in NumPy, you would say, no, I need only 8 bits, so it's 1 byte to hold, because it's going to be a really small number. Or I say, no, it's going to be a bigger number, so I allocate 16 bits, so 2 bytes. Here, by default, Python just takes 28. So that's why NumPy is much more useful, where you have a lot of numbers and you do a lot of number crunching.
Is there a reason why it's 28?
Why exactly 28, or why it's so many? What is it?
No, why exactly 28?
I don't know the exact reasons, but okay. So behind the scenes, it basically holds all kind of attributes, all kind of information, additional information about this integer. So Python not only holds the actual value there, but also holds, for example, the information that's an integer in there,
right,
and all kind of other informations in that location. So it needs more space to have this extra information that then later on can provide all kind of flexibilities that Python has that, for example, C doesn't. Okay, so I think I didn't talk about this, that one of the big differences between languages is the level of how easy it is to write a program, and the trade-off,
level of restrictions.
level of restrictions, level of, and not only that, it's, I mean, you can write everything like this also in C. You would just write 10 or 50 times more code because you are much lower level code. So the usual way I compare is that we are using, if you're building you want to build a building and you have these prepared blocks, you can build much faster, but in a way you are restricted to it's not a good example actually, because you aren't really restricted in Python, but in these bigger building blocks, you can build these big things easily. You work a lot less. You have some costs there, other costs, okay? And then, so the big difference is like C is more designed to write really, really fast programs. And it doesn't matter that it takes you, the programmer, 10 times more time to write it. Because what's important, that it's going to be really, really fast. Because it's going to be executed so many times, or for whatever reason, okay? It must be really fast. On the other hand, on other programs, we don't care about so much about the speed of the program. Way more important that the programmer can save time. Okay, so you don't care if your program will run 5 minutes or 4 minutes or 1 minute. Usually you don't care because you go and go and drink a coffee anyway, and it doesn't matter for you if it's 1 minute or 5 minutes. Even with 1 minute, you wouldn't wait. You would take the coffee break. Okay. On the other hand, it matters to you if it runs for 1 minute or 2 days. So I'm not saying that it doesn't matter at all, but it depends, okay? So the question is how much you are ready to invest in that extra speed, okay? And so languages differ in this area as well, and all kind of flexibility. So Python is on the side of I'm okay using more memory and being slower as long as the programmer can work faster, and that's the optimization there. Okay.
Yeah. Thanks.
So, else? Did you have?
No, I think that was it.
Okay. So the getsizeof is 28. Now 42 is just another number, so it's still the same size. It's just another integer. If I take a floating point, for to me surprisingly reason, it takes less memory. Okay, it's a floating point number, but it takes less memory. A string, an empty string, so you don't have anything there, it already takes 49 bytes. Okay, totally seems like totally waste of memory, but we have to remember that we get a lot of value out of it in the end. Letter A, it's 50. So now you can see that on the base of 49, you get the actual, what we call payload, so actual data. So you have 1 character is 50, 2 characters is 51. So just any character just adds 1 more byte because it now takes up the space. So the 49 is just the overhead of being able to handle a string. Okay, it's not really important for us now. The main thing I wanted to show you is the fact that you can call a function. So what we actually discussed earlier, but when I designed the slides, I didn't think about going over that part. the exercises. So that this was supposed to be sort of the introduction of modules and the fact that you have attributes and methods. So the main function. In some languages, you actually have to define a function called main, and that's going to be code. Python is not such a function. You could see that we already wrote programs without anything else, just writing in the commands. So you don't need this, but I think I recommend to use to put everything in a function. And we'll learn about functions later on. But if you get used to this thing that you put everything in a function, so you say def some name, parentheses, colon, and then you put the code indented to the right, let's say 4 spaces. So moved to the right 4 spaces, and that's how you write the code. It's a good thing to get used to write everything in functions. Okay, and later on we'll get to the point where we start actually writing functions and using them. But the idea of these functions is that to separate things that you work on, so you won't have a 100 or 1,000 line long program that's really hard to read and understand and locate issues. Okay, so now I have a function here, but this is just the definition of the function. If I run this program, nothing will happen. You won't see anything because I just defined the function. I didn't run the function. I didn't call the function. Okay, so in the next, or didn't invoke the function. That's another word for these things. And I'm using all these words because you will probably encounter these words in various contexts. Okay, so you usually run the function or call the function or invoke the function. These are names, which is you can see in the next slide. So here what we have is we still have the same definition of the function. Okay, that didn't change, the definition of the function, of the main function. But then I have 3 lines. So the interesting one here, the really interesting one is calling the function. When I say main and parentheses, this is when I tell Python to actually execute the steps that are in the function. The 2 print statements before and after I only added, so it's going to be easier to see the actual sequence of what happens. Okay. So when I run this program, what happens is that Python sees, oh, you defined a function, good for you, and put it aside. Understand that it's okay and puts it aside. Doesn't do with it anything. And then it says, oh, you want to print the word before? Okay, I printed the word before. Then it says, now you want to call a name called main. Now Python goes and looks up if there is anything called main here. Okay. Because we already defined the main earlier, it finds it, and then it starts executing these lines, whatever the content of the function. And it executes hello and then world, and then it runs out of anything because the indentation, so that's an important, the indentation ended. So the next line that you can see is not indented inside. It's not at the same depth. It's on the level of the D, of the letter D. And therefore, Python understands that the definition of this function ended. Okay, we got out of the function. Other languages make it clearer because they put parentheses, curly braces, sorry, around it. So in other languages, you would start a function with a curly brace and end it with a curly brace. And in a way, it's easier to see then when's the end and when is the beginning, when is the beginning and when is the end of a function. In Python, it's a usual thing that I encounter people who start learning Python that's unclear what is the end. So the end is not calling print. It's not calling main. There's nothing to do. The end. So Python knows that the definition ended because one of the statements started on a new line on the beginning of the line. Okay. So then the execution of main finishes and Python goes on and prints out the after. So executes the code after the line after, which is prints out the word after. Okay, and so a couple of notes here. The word main is not something special. I could call it kukuriku or hello or whatever, just any name. Okay, there are rules what can be the names of a function. So letters and digits and underscore, I think these are the limitations. But anything can be. Okay.
Can it be a name that has already been used before, or would that change the original function?
So it can be, and it will override the original function.
Right.
So it's very much recommended not to do that. And the bad part, that Python doesn't even complain if you do that. Okay, so Python won't say, okay, you just overrode the print function and it does something totally different now. And Python doesn't care. It just will do whatever you told it to do. And there are external tools that you can look at them later on that can look at your code and say that, oh, there is some issue here because you just changed a built-in function. Okay, so there was a built-in function and you replaced it with something else. You could put, say, print equal 42. So you don't even need to replace it with another function, which is in a way really nice, flexible, as I said, but can be really dangerous. Can lead to mistakes and mistakes that then we spend too much time finding out what the source of a problem can be. Okay. Anyway, so I'm just saying it's my recommendation that you use the word main for the main function. It's clear. It's usually then it's actually small, and then it will go call other functions, whatever. But it can be a good practice. Okay. Any other questions here? No. What else did I want to say? I don't remember if there was anything else. Okay, so let's go on. Indentation. Okay, so a couple of things here already if you came back to this. So the fact that, so this is the fact that we moved it inside. Okay, it's a little bit to the right. It's called indentation in, I don't know if it's in English in general or just in programming world. There are these funny words that I know from programming and I have no other connection in English. So the fact that it's inside a little bit, that's called indentation. The indentation in the function must be the same level all the time. Okay. So if I put the next print in one space less, that would give a syntax error for Python. So Python would say, okay, no, we can't do this. And the depth of this indentation actually doesn't matter to Python. So it can be 1 space, 2 space, 27 spaces, doesn't matter, as long as it's the same in the same function. The recommendation, and that's what comes in the next slide, is to be 4 spaces. That's sort of the recommendation because it's sort of quite readable for most of the people and so on. Because some people like to put in 2 spaces, but others can't, they have some difficulty noticing the indentation if it's only 2 spaces. That's sort of the standard. Okay, now there is this other thing that, sometimes I skip over this, but now I have no excuses, so I'm going to explain it. Sometimes we get, you will see this kind of code in lots of examples, and that's part of the reason maybe to explain that early. This basically, so I normally at this point I ask the people, how do you call yourself? So how do you call yourself?
Nora.
Do you really, when you talk to yourself, do you say Nora? Don't do this, Nora,
no.
don't do. You say I or me or something.
Oh,
like
yeah,
that.
right.
Right? Okay. And this is the point that I'm trying to make here, that you yourself, everyone calls themselves I or me or myself or whatever is the correct English word for that, depending on the situation. And everyone else calls you by your name, given name, or your nickname, or some external name. And this is sort of the same thing here. So this is 2 underscores on both sides of the word name. And this is a variable in Python. This is actually the thing that you have two underscores on both sides has a special name in Pythonese. Okay, so it's a separated language, Pythonese or whatever. It's called a dunderscore because it's a double underscore. Okay, so and then we don't have to say two underscores on both sides because it's way too many words. So we say just dunderscore name. So the dunderscore name is a variable, a built-in variable of Python that contains how the Python program I just looking at calls itself. Okay, and if you run this program straightforward, like if I type in Python conditional main, then it will call itself this word, which is again underscore, but this is a string. Notice that this is a string, this is a variable. How can you see it besides the colors?
What it's called, the parentheses, yeah.
The parentheses. The parentheses is because of the parentheses, we know that it's a string, and because it's a variable, we don't put in parentheses. Okay? So so this is a string. So if you run the program as Python and then say conditional main py, then it will call itself main. And then this conditional statement that we haven't learned either yet, but we'll get to that, will be true. And so the main function will be executed. Okay? And if this thing is loaded as a module, so every Python program can be also a module, just like sys or maths, you could import this conditional main, okay? And then the name would be the actual file name. So then the underscore name would contain conditional main.py because someone else coded this program, imported this program. So it's sort of the same thought that the program calls itself main all the time, but if someone else calls it, then it calls it by name. Okay, so, and then this condition will be false, and then the main won't be executed. So this is a protection that people put in when they want to have their program to be run both as a script, as a module. Probably I should have said at the beginning that most of the people could just skip over this section and this part because at this point it's not that interesting. Later on it's going to be. But on the other hand, I have this slide here, so I should have explained it anyway. Okay, so if it's unclear at this point, why would you need this? You don't really need this now. Okay, you can just call main yourself, and then later on when we get to the point of creating modules, then we come back to this and discuss it. Okay. No, I don't remember how long have we been talking, but it sounds way too long. Let me check sorry, not this one. So we have quite a lot of things here to cover. I think let's take a couple of minutes break now from the video, and then we come back to actually talk about input-output things. Okay, so where is, I keep not finding the, oh, okay, I can find now. I stopped recording and then see you in a couple of minutes. Okay, bye-bye.